Hi, good day, and welcome to my first video on sum and products of quadratic roots. Now, when we're doing this topic, the only assumption that I'm going to make is that you understand how to solve a quadratic using the quadratic formula. Now, in case you cannot use the quadratic formula to solve a quadratic equation, to find a video on this is very easy. All you have to do is go to my website www.ilovelessons.com. You need to click on free maths videos. It's on the menu bar and scroll down. You should see a blue button with quadratics written on it. Click on the blue button and then look for video 23. That video will show you how to solve a quadratic using this formula. Only after watching that video, then you should come to this video, because this video, like I said, assumes that you know how to use this formula. So let's get started. So I'm going to show you a little magic trick, and this magic trick will help you understand the purpose of this topic. So here we have a quadratic equation. Now you know it's a quadratic because there's an x squared, an x, and an item without x. As you all know, the number touching x squared is a, the number touching x is b, and the item without the x is simply c. So I'm just going to I'll put a here. This item here is b. You notice b is not 11, it's minus 11, and the item without the x is c. Now, usually when you solve a quadratic, you usually get two answers. Now, when you're solving a quadratic, you're really supposed to put the y equal to 0. Because when you're solving a quadratic, you're really trying to figure out where the curve cuts the x-axis. And when the curve cuts the x-axis, y is equal to 0. Now, when we solve this quadratic using this formula, we throw in a, we throw in b, we throw in c, and we get our two answers. I am letting you know the two answers will be 5 on 2 and 3. So when we solve this particular quadratic, we get two answers. Now, these two answers, you can call them solutions, or you can call them roots. But the point is, we get two answers. The two answers, we are going to call them alpha, and we are going to call them beta. So the two answers, or the two roots or two solutions, whatever you want to call them, are 5 on 2 and 3. To be honest, it doesn't matter if you call the first one beta and the second one alpha. So let me show you this magic trick here. What we're going to do when we have this quadratic, I'm going to just write it back here quickly. You're going to have 2x squared minus 11x plus 15. And I'm just going to put a 0 on this side. For this magic trick to work, the number touching x squared has to be 1. So we have a little problem here with this question. The number touching x squared is 2. We need the number touching x squared, or a, to be 1. Now remember, I'm not too sure if your teacher ever told you this, but in an equation, you're allowed to do anything on one side once you do the same thing to the other side. So here's what I'm going to do. I am going to divide everybody on this side by 2. Now if I do that, I have to divide the other side by 2. Now technically, I am dividing by a. So I am dividing everyone here by a, because remember, a is 2. I'm going to divide the b value by 2, and I'm going to divide the c value by 2. When we do that, the 2 and the 2 will cancel out. So I'm just going to cancel it out here, because 2 divided by 2 is 1. Minus 11 divided by 2 will give you minus 5.5, but I'm going to leave it as a fraction today. And 15 divided by 2, while I know it's 7.5, I'm going to leave it as a fraction. So technically, our a value here now is 1, because if there's nothing touching the x squared, is automatically 1. And over here, we are really dividing b by a, because b was minus 11, so we're dividing b by a. And over here, we're really dividing c by a. Now let me show you the trick I was talking about. Remember when we solved the quadratic, we got two roots, 5 on 2 on 3. Let me see. I am going to take alpha and I am going to add it to beta. So we are going to take the two roots and add it. Right? So we're going to take the two roots and add them. So the first root is 5 on 2. And the second root is 3. And we are going to add them. Now for this topic, I would seriously advise that you work everything in fractions and try to avoid decimals. It may sound trivial, but in harder questions, it's really important that you keep everything in fractions. So I'm going to add it using my calculator. All you have to do is use the fraction buttons. So 5 on 2 plus 3. And we will get, if we add this up, we will get 5.5. Now it's also important in this topic to work in improper fractions. Right now we have a mixed fractions. So 5 on 2 plus 3 is 5.5. But if we convert this to a mixed fraction, we'll obviously get 11 on 2. 5 by 2 is 10, plus 1 is 11. So we will get 11 divided by 2. Right? So here's what I'm going to do now. I'm going to take the same two roots, and instead of adding it, I am going to multiply them. So I am going to take alpha and multiply it by beta. So my alpha value is 5 on 2, and I'm going to multiply it by beta, which is 3. If we multiply this, but 3 is the same thing as 3 on 1, 5 by 3 is 15, 2 by 1 is 2. So if we go back to this equation here, where a is 1, this magic trick only works if the number touching x squared is 1. You will notice that when we add the two roots, we get 11 on 2. But look over here. What do we have touching x? Minus 11 on 2. Anytime we add the two roots, we get the opposite of what is touching x. You notice here is positive 11 on 2, and over here it's minus 11 on 2. Great. And anytime we multiply the two roots, we get c divided by a. In other words, the item without any x in it. So I know it's not an amazing magic trick, but this little trick has a lot of advantages in knowing it. In other words, anytime you add the two roots, whatever we get, we just need to change the sign, and that will help us figure out what is touching x. Anytime we multiply the two roots, whatever we get, that will be the item without any x in them. In other words, c divided by a. So seeing this trick isn't too useful unless I actually do a question with you. All right? So I have summarized the rules here. Alpha plus beta, which is the two roots, will give us b divided by a, but the opposite of b divided by a. So I put a negative sign here. Some textbooks have the formula written like this. Some textbooks would throw the minus sign on the other side. You notice if they throw the minus sign on the other side, the minus sign belongs to everybody on this side. So you have to put the whole thing in brackets and then the minus sign. And alpha multiplied by beta will give us c divided by a. C divided by a. So I'm going to leave the rules here, and we're going to do a couple examples. I'm going to show you how you could use this in a real past paper question. Well, this is not a past paper question, but something that resembles a past paper question. All right. So let me see. let's say I have, this will be E. Let's say I have a quadratic. I tell you the quadratic is 2x squared plus 12x minus 3. And I want you to find two things. I want you to find alpha plus beta, and I also want you to find alpha multiplied by beta. So you have two things to find in this question. But I want you to figure out these two things without using this formula, without solving the quadratic. So you're not allowed to solve the quadratic and get your two answers and just add the two answers. Here's how you do this. When you're doing these types of questions, you have to make sure the number touching x squared, which is a, it must be 1. So this whole expression is really supposed to be equal to 0. I forgot to write the 0, to be honest. So here's what we're going to do. We know A is 2, B is 12, and C is minus 3. We will need to divide every one here by 2 to get rid of this 2. So let me do that. Let me visit him, divide him by 2. Visit him, divide him by 2. Visit him, divided by 2. Remember, A is 2, so we're already dividing 12 by 2, which is already B divided by A. And over here, we're already dividing C by A. So when I'm going to put the summary downstairs here, let's see. The 2 and the 2 will cancel out to give you 1x squared. There's no need to put the 1. 12 divided by 2 will give us a really nice number, 6. And 3 divided by 2, minus 3 divided by 2, we're going to leave it as a fraction. We are not going to put minus 1.5. All right. So remember, this over here is really B divided by A, right? Because we divided B by A. And over here is really C divided by A. So the B divided by A value is 6, and the C divided by A value is minus 3 on 2. So let's go and use the formula now. The examiner asked us over here to find alpha plus beta. To find alpha plus beta, we just have to take the B divided by A value and apply a minus sign to it. When you're applying a minus sign to a number, you're already making the number the opposite. So that's how I like to think about it. So B divided by A is 6. What's the opposite of positive 6? The answer is negative 6. That's the answer for that one. To figure out alpha multiplied by beta, we just have to take the C divided by A value. You do not make this one the opposite. So C divided by A is minus 3 on 2. You do not make it the opposite. It's just minus 3 on 2. And that's the end of that particular question. Let's try a slightly harder one. Right? Well, I guess I could erase the magic trick part. All right. Let's say we have, oh, this is a good one. We have minus 2x minus 3x squared is equal to minus 1. And the examiner wants you to find the value of alpha plus beta. And once again, he wants you to find the value of alpha multiplied by beta. So I think this quadratic, and I know it's a quadratic because there's an x squared, an x, and something without an x. I usually like my x squared to come first, then followed by my x's, then the c value, and the equal sign. After the equal sign, there must be an equal to 0. So I think we need to rearrange this here a little bit. The minus 1 definitely needs to jump across to give you positive 1. I don't think we have a choice there. The minus 3x squared will shift around, the minus 2x will go in the middle. So let's see how this will look. I think I would end up, if we rearrange, minus 3x squared minus 2x plus 1, because we threw it across, is equal to 0. Now for these formulas to work, the number touching x squared must be equal to 1. So this minus 3 is a problem. So I think we need to divide out throughout by minus 3. Minus 3, and remember, I prefer if you keep everything as fractions in this topic. These two will cancel out, which will definitely give you x squared. We use a different color so you don't get mixed up with it. Let's see, you're going to get x squared. Well, you end up with 2 divided by 3, and two minus signs when you divide them will give you positive. So you can get 2/3 x. A positive divided by a minus is a minus, so you'll get 1 minus 1/3 here. All right, so remember, whatever is touching the x here, remember we're already dividing b by a. So this here is b divided by a, and this here is c divided by a, because we took c and we divide out throughout by a. So the examiner asks us now to find alpha plus beta. According to this formula, alpha plus beta is the opposite of the BA value. How much is BA? 2/3, positive 2/3. We apply a minus sign there or make it the opposite. So that's the answer for this one. To find alpha, multiply by beta, use this formula, which is just C on A. And that's simple. It's just minus 1/3. You don't make that one the opposite. All right, so that's 2 examples of how to find alpha plus beta and alpha beta. I'm just checking the time here on the video. So far, it's almost 17 minutes. All right, let's try. I think we have time to do other type of question. So let's see. All right. Now here's what. In the last 2 examples, I gave you the quadratic equation and I asked you to find alpha plus beta and alpha beta. This question is going to be wrong side, well, reversed. I am going to ask you to find the quadratic. In other words, I am not going to give you the quadratic equation. You don't know how much is A, you don't know how much is B, and you don't know how much is C. But I am telling you, you're given 2 pieces of information. Given that alpha is equal to 2 and beta is equal to minus 3. This is a very simple example. This is the easiest one I could think of. So I am telling you alpha is 2 and beta is minus 3. The 2 roots are 2 and minus 3. And I want you to find back the original quadratic equation, right? So, in case you can't remember, these formulas only work when the number touching x squared is 1. So, that means if you have the quadratic ax squared plus bx plus c, which is the general format of a quadratic, these formulas will not work unless the number touching x squared is 1. So we have to divide out throughout by a. I believe I showed this at the beginning of the video, but don't no harm doing it back. The a and the a will cancel out, giving you a 1 here. But I'm not going to write the 1. So to figure out what number is touching x, I just have to figure out the value of b divided by a. And to figure out what goes here, I just have to figure out how much is c divided by a, which is really easy. To figure out b divided by a, because I need b divided by a, I'm going to use this formula. I'm going to add the 2 roots, and whatever I get, I'm going to apply a minus sign to it. When you apply a minus sign to an expression, you're already making it the opposite. So, b divided by a is alpha plus beta, and you have a minus sign here. So we have a formula to work with. How much is alpha? Alpha is 2 and beta is minus 3. And you notice what happened inside the brackets? A positive met up with a negative. We all know when a positive and a negative meet, you ultimately get a minus. So erase that and put a minus. So let's work this out. I prefer to work underneath here. 2 minus 3 is minus 1. And what's waiting outside? A minus. So 2 negatives make a positive. So it's positive 1. I'm not going to bother to write the positive. How do you calculate C divided by A? Well, we have a nice formula there. C divided by A is alpha multiplied by the beta. Super easy. Alpha is 2. Beta is minus 3. Multiply these two, we get minus 6. So, we just have to go back here now. We know how much is B divided by A. B divided by A is 1. So we can just go over here. Erase B divided by A and we put 1. And C divided by A is minus 6. And a positive, well, this looks weird. A positive divide, when a positive meets a negative, you get a negative. And that is the equation. This is the original quadratic equation. This was the quadratic equation they asked us to find. But like I said, this is the easiest example I could think of. I would never give you this in an exam. It's too easy and it has no tricks in it. So let's try one with a trick in it. All right. So, same question, different values. Given the quadratic, find the quadratic, sorry. Given that alpha is, let's try a half and minus 2/5. Now, it's a really good idea in these questions to work with fractions. All right, so remember, we are working with this. X squared plus B divided by AX plus C divided by A is equal to 0. I already divided the quadratic by A. So to figure out what is touching X, we just have to figure out the value of B divided by A. So let's use the formula. B divided by A is equal to minus open brackets alpha plus beta. And of course, to find C divided by A, we just have to take alpha and multiply it by beta. And once again, I'm going to keep reminding you, please stick with fractions. And you'll see why in a little while. So, let's substitute in here. Minus, how much is alpha? Alpha seems to be a half plus beta is minus 2/5. A negative and a positive came together, they touch, so they ultimately give you a negative. So what I'm going to do, I'm going to work out this, and whatever I get, I'm going to apply a negative sign to it. So I'm just going to use my calculator here to do it quickly. You can use your fraction button. A half minus 2/5. I am getting, in the brackets, you will get 1/10. And what's waiting outside? A minus sign. So, a minus 1/10. I'm just going to write minus 1/10 here. So when I work out the brackets and apply the minus sign, I get minus 1/10. Great. Let's try C divided by A. For C divided by A, you have to take alpha, which is a half, and you have to multiply by beta, which is minus 2/5. So that little arrow there. So how are we going to multiply this? 1 by minus 2 is minus 2. 2 by 5 is 10. So we could simplify this if we wish. We get minus 1/5. Great. So we have C divided by A, so we know it's minus 1/5. And B divided by A is minus 1/10. Let's put it inside here. Actually, let me just write it bigger here. So we have x squared plus b divided by ax plus c divided by a is equal to 0. Just a replacement game now. B divided by a is minus 1/10. A positive meets a negative, so let's just put the negative. C divided by a is minus 1/5. Positive and a negative happens to come together again, so you get a negative. Now, while this is well, correct-ish, that's the term I'll use, what we need to do whenever we end up with fractions and we have denominators, we need to get rid of them, okay, to get the full marks in the exam. So here's what you do. You look at all the denominators. We have two denominators, 10 and 5. And all you need to do is find the LCM. The LCM of 10 and 5 is obviously what? 10. What we are going to do, we are going to multiply everybody on top here by 10. But if we do that, we have to multiply the other side by 10 also. So I'm going to visit everyone. I'm going to multiply him by 10. I'm going to multiply him by 10, and I'm going to multiply him by 10. 10 by x squared is 10x squared. Here the 10 and the 10 will cancel out to give you minus 1x. 5 into 5 is 1, 5 into 10 is 2, so you end up with minus 1 by 2. If you multiply that, you will get minus 2. This here is the quadratic equation that you're asking for. So the moral of the story is, when you end up with denominators, because you're working with fractions, find the LCM and multiply out throughout by 10. I just forgot to show this, but it should have been obvious. If I multiply the 0 by 10, I'll get back my 0. All right, so I just want to double check one thing on my calculator here. I just wanted to make sure I didn't make any mistakes, and I did not make any mistakes, and everything is fine here now. Right, so this is how you go about getting back to quadratic given the two roots without using the formula. Right, so checking the time on my camera now, it's 27 minutes, that's almost a half an hour. All right, so in my next video, I'm going to show you some other questions involving the alpha and the beta. All right, so stay tuned for my next video. Hi, and welcome to my next video on sum and product of quadratic roots. Now, in this video, I'm going to show you a different type of question that can come in the examination. In the last video, we were using these formulas. For these types of questions, we really won't need these formulas. We are actually going to be needing these formulas. So I would suggest that you learn off these formulas by heart for the examination. So let's get started on these types of questions. Here at the beginning of the question, you're being told that you have a quadratic, you have no idea what the quadratic is. It could be anything in the world, but all they are telling you is that when you add the two roots, the alpha and the beta, you will get 4. You don't even know how much is alpha, and you really don't know how much is beta. Alpha could be 1, beta could be 3 to give you 4, or alpha could be 2, beta could be 2 to give you 4. You just don't know. Now, and they are also telling you that if you take alpha and multiply it by beta, you will get minus 1. And now they are asking you to find alpha squared, beta squared. So they want you to find the value of this. Now, I do not want you to think of this as a simultaneous equation. I do not want you to make alpha the subject and substitute it into b, and from there you would find the values of alpha and beta and throw it in. That's not how they want you to do these types of questions in the examination. So here's how. I'm going to do about 6 examples so you get the hang of it. If they ask you to find alpha squared multiplied by beta squared, can't this be rewritten like this? Alpha, beta in brackets and the whole thing squared? Doesn't this really mean that everyone inside here gets squared anyway? So this and this is the same. So according to the information they give us on top, anywhere you see alpha, beta, it's perfectly okay to replace it with minus 1. So I'm going to do that. In brackets, I see an alpha and a beta. I'm going to replace it with minus 1, and don't forget that we have to square it. Minus 1 squared is positive 1. We are finished. That's the end of that question. Let's try part B. They want us to find 1 on alpha plus 1 on beta. Remember, wherever we see an alpha plus beta, we can replace it with 4. Wherever we see an alpha multiplied by beta, it's perfectly okay to replace it with minus 1. This one is not as simple as this one. So here's what I suggest we do. I suggest we find the LCM since it's 2 fractions. Anytime I'm told to add 2 fractions or minus 2 fractions, the first thing that automatically jumps into my head is LCM. The LCM of alpha and beta is just alpha beta. Alpha into alpha beta will leave us with beta. Beta by 1 is beta. Plus beta into beta will divide. Well, when this expression gets divided by beta, you will get alpha. Whatever, in case you don't believe me, if I take alpha, beta, and divide it by beta, the 2 betas will cancel out to give you alpha. And whatever you are left with, you multiply it by the top. So alpha by 1 is just alpha. So here we end up with beta plus alpha on top and alpha beta underneath. Now, in case you didn't realize, alpha plus beta is obviously the same thing as alpha plus beta. It doesn't matter which order you add. So alpha plus beta is 4 and alpha beta is minus 1. So 4 divided by minus 1 is minus 4. And we're finished. Let's try something harder. These are too easy. Let's try something with a little more spice in it. All right. Let me see here. Oh, here's a good one. So C. If I want you to find alpha divided by beta plus beta divided by alpha. Once again, I see 2 fractions. So I'm going to find the LCM. The LCM is beta multiplied by alpha or alpha multiplied by beta. Anyhow you want to write it. Just know that beta multiplied by alpha is obviously the same as alpha multiplied by beta. Beta into this expression will leave you with alpha. Alpha by squared is alpha squared. Alpha into this expression will leave you with beta. Beta by beta is obviously beta squared. Right. Now here's what I don't want you to mix up. X plus y squared is not the same thing as x squared plus y squared. Your brain might tell you that, hey, let's square everybody inside here, but that's completely wrong in maths. We know x plus y squared is x plus y multiplied by a next x plus y. And I'm telling you, if you multiply this out, you will not get that. You will not get x squared plus y squared. So, how do we figure out this equation? Well, that's this expression, sorry. Luckily, we have this equation. Alpha squared plus beta squared is the same exact thing as, and I'm going to write back the same exact expression, alpha plus beta in brackets squared minus 2 alpha beta, and we're dividing the whole thing by beta alpha, which I'm going to rewrite as alpha beta. Now we can do a substitution. Anywhere I see alpha plus beta, I can replace it with 4. Anywhere I see alpha multiplied by beta, it's minus 1. So I can replace these 2 guys with minus 1. So in the brackets, I'm going to replace this with 4. This I'm going to replace with minus 1. And alpha beta, again, replace it with minus 1. And I'm just going to simplify it, and that will be the end of our question. So let's see. You're going to have 4 squared. That's this guy here. Minus 1 multiplied by minus 2 is positive 2. And underneath we have minus 1. Almost finished. 4 squared is 16 plus 2 divided by minus 1. 16 plus 2 is 18. 18 divided by minus 1 is minus 18. That's our final answer. But we couldn't get out this question without memorizing this formula. And I don't think that formula comes in the formula sheet in the exam. You need to learn it off. Right? Now, similarly, now I just want to hold this answer because we're going to, where's the alpha? Alpha squared plus beta squared. That's the top. So I'm just like, so the top works out to 16 plus 2, which is 18, before we divided it by minus 1. So I'm just going to hold this answer for later on in a question that I plan to do. So alpha squared plus beta squared, if we ever see it again in this particular question, we will get 18. All right, so alpha plus beta squared is the top part of the question, and that only gave us positive 18. Only after we divided it by the minus 1, then we got the minus 18. Right, so I'm going to hold that question for later on. That part of the question for later on, sorry. All right, so let's try another question. All right, let's try, oh, here's a nice one. This would be D. 1 on alpha squared plus 1 on beta squared. So, once again, we see two fractions. I'm just automatically going to find the LCM. This into this expression leaves you with b squared. B squared by 1 is just b squared. B is beta. Beta squared into this expression gives you alpha squared. Alpha squared plus 1 is alpha squared. So, remember, beta squared plus alpha squared, we can switch it around. It doesn't really matter. 1 plus 2 is the same thing as 2 plus 1. And underneath, we have alpha squared, beta squared. Now we know from our first question, it was A, I believe it was A. When both of them have a square and you have a multiply here, you can erase both of them and put a square here. But that's only if they're being multiplied or divided, not if it's being added or subtracted. Okay? Right. So, remember I had to hold this answer from the last question. The reason I wanted to do that was to save time. If I had to find alpha squared plus beta squared, I would have to throw it into this formula and work this out. But we know from the last question, if we do that, we will get 18. I just didn't want to rework it. I was being lazy. And alpha, beta, it's okay to replace it with minus 1 and don't forget to square it. So we're almost finished. 18 divided by minus 1 squared. When you square anything, you get a positive. 18 divided by 1 is 18. That's the answer for this particular question. All right, let's try a couple more. This is D. Let's try E. Let's check the time here. It's only 10 minutes so far. I'm trying to hold the videos at 30 minutes max. Try my best. E. 2 on alpha plus 2 on beta. Let's try this one. LCM again. Alpha, beta. Alpha into this will leave us with beta. Beta by 2 is 2 beta plus beta into this expression gives us alpha. Alpha by 2 is 2 alpha. All right. Now remember, anywhere we see an alpha plus beta, we can replace it with 4. 2 beta plus 2 alpha is different to alpha plus beta. However, we can factorize out the 2 because both of them have a 2. So 2, open brackets, beta plus alpha divided by alpha beta. By now, you know alpha plus beta is the same thing as, beta plus alpha is the same thing as alpha plus beta. Which means we can replace this with 4 and this with minus 1. 2 by 4 is 8 divided by minus 1. Our answer is minus 8. Any more here? Nope. I think that's all the examples I had lined up. Well, actually, we could try this one here. I can show you how to find alpha cube plus beta cube, right? Let's do one just in case it comes in the exam. Right? It looks a little complicated. It's long, but believe me, it's not complicated. I think this is E, not too sure. E or F, I can't remember now. Let's say the examiner asks us to find alpha cube plus beta cube. Well, all we have to do is go to this crazy looking formula. Alpha plus beta, big open brackets here, another alpha plus beta squared minus 3 alpha beta, right? All we have to do is go and replace any alpha plus beta with 4 and any alpha beta with minus 1, and that's it. Nothing complicated. Replace that with 4, right? You have a big open brackets here. Remember, you're replacing this with 4 also. So 4 squared is 16 minus, and alpha beta is minus 1. Minus 1 multiplied by minus 3 is positive 3. So we just have to add the 16 and the 3, and you will get 19. And then you take the 19 and multiply it by 4, which I cannot do in my head. So I will use my calculator, and the answer is 76. Very straightforward. So in my next video, we're going to utilize both sets of formulas in the same question, right? And that, well, once I do that, that should be the end of this topic. And so I think I'm covering this whole topic in 3 videos. All right. Of course, for a full listing of all my videos, you can go to ilovelessons.com, click on free maths videos or free and maths videos. You'll see it on the menu bar. Just click on it, scroll down, and you'll see tons of free videos with no sign up required. You just dive in, click on whichever video you want, and you begin to learn. So take care and stay tuned for my final video on this particular topic. Hi, good day, and welcome to my 3rd video on the sum and product of quadratic roots. Now, I'm going to describe another popular type of question that comes in the exam, and as promised in my last video, we will be using these formulas from the first video in this series, and of course we'll be using these formulas also from the second video in this series. So this is a strange question. I have a good feeling that for this video you'll probably need to watch it twice. It's a trouble question. So let's get started, and I'm going to be moving really slow because my students from experience, they always get problems with this particular type of question. So let me explain the scenario here. You've been given a quadratic, 2x squared minus 4x minus 6. So you've been given this quadratic in the exam, and they are telling you it has 2 roots, obviously, because if you solve it you will get 2 answers. Obviously, if you solve it with this formula, most likely you will get 2 answers. But we're staying away from this formula. In fact, we don't care what the 2 answers are. We are just naming them alpha. It could be anything in the world right now because we haven't worked it out. And beta, which could be anything in the world because we haven't worked it out as yet. Now they are telling you that they want you to find a new quadratic, not this quadratic. You have to find a new quadratic with different numbers, because this new quadratic has 2 different roots. The roots are not alpha and beta. Alpha has changed to 1 on alpha, and beta has changed to 1 on beta. So if these 2 roots give you this quadratic, if I change the value of the roots, if I were to find back the quadratic it came from, it would not look like this. In fact, the numbers would change up. So that's what we're doing. I am telling you there are 2 new roots, and we want to find back the original quadratic. So I wrote back the same exact quadratic here. I changed nothing. Remember, for this topic I told you that the number touching x squared has to be 1 for these formulas to work. So what I'm going to do, I'm going to divide out throughout by a. A happens to be 2. So I'm dividing out throughout by 2. Of course, if I divide this side by 2, I have to divide the other side by 2. But 0 divided by anything is 0. This and this will cancel out. We will get a 2 here, and we'll get a 3 here. So lucky for us, we did not get any fractions. So that means we end up with x squared minus 2x. That's minus 2x. Minus 3 is equal to 0. Now, for D, we can apply these formulas. Remember, this over, we just took B and we divided it by A. So this over here is B divided by A. And over here, this is C divided by A. So let's apply these formulas here. And I'm going to make a note of each result. Alpha plus beta is minus B divided by A. In other words, it's B divided by A with a minus sign. In other words, the opposite of B divided by A. So, B divided by A is minus 2. Therefore, alpha plus beta is the opposite of that. So, it will be positive 2. Now, remember I told you these two formulas are basically the same formula. But I like to have both in front of me. And minus alpha plus beta is equal to B divided by A. B divided by A is minus 2. Right? So anywhere I see alpha plus beta, I can replace it with 2. Anywhere I see alpha plus beta with a minus sign, I'm allowed to replace it with minus 2. Alpha multiplied by beta is C divided by A. C divided by A is minus 3. You don't make this one the opposite. Take it as it is. Minus 3. So anywhere I see alpha multiplied by beta, I'm allowed to replace it with minus 3. Alright, so I've just showed you how I got these values. So I'm going to erase this here. I need a space for this particular question. Alright. So, this new quadratic has a new root, 1 on alpha. I will be calling 1 on alpha, alpha 1. And the new beta, the 1 on beta, I will call it beta 1. So for the new quadratic, to figure out what is touching x, right, I just need to take the new root, the new alpha root, add it to the new beta root, and whatever I get, I apply a minus sign to it, or make it the opposite. And that will tell me what is touching the x value. If I want to figure out what doesn't have the x attached, remember it has x squared, x and something without x, I just have to take the new alpha value and multiply by the new beta value. And that will give me C on A. So let's see how this works. Remember, we always work with fractions. We try our best to work with fractions if we get a fraction. So let's apply this formula first. Right. Alpha 1 plus beta 1. And whatever we get, we are going to take the opposite. And that will give us B on A. So how much is alpha 1? 1 on alpha plus 1 on beta. Remember, alpha 1 is 1 on alpha. Beta 1 is 1 on beta. So let's add this up. From the last video, you'll probably realize what I'm doing. I'm finding the LCM. Alpha into this will leave us with beta. Plus beta into this will leave us with alpha. And of course, we have to take the opposite of this answer. So let's see what we get here. Just excuse me here, trying my best to clean it up. Alpha plus beta. Remember, alpha plus beta is 2. And alpha beta, we are allowed to replace it with minus 3. So a negative and a negative will give me a positive. So this is 2/3. So far, this is what we know. For the new quadratic, alpha squared plus B on AX plus C on A. We're trying to find, this is the new quadratic. We just figured out how much is B on A. We added the two new roots and we took the opposite. And we ended up with 2/3. So B on A is 2/3. We just need to figure out C on A. To figure out C on A, well, we have to take the two new roots. Let's clear up here. Oh, let me clear up here because we don't need this anymore. What we're going to do is take alpha 1 and multiply by beta 1. We have to multiply the two new roots to get C on A. So alpha, this is really 1 on alpha multiplied by 1 on beta. Remember, alpha 1 is the same as 1 on alpha. Beta 1 is the same thing as 1 on beta. And this will give us 1 by 1 is 1. And alpha by beta is just alpha beta. But we know from here, anywhere we see an alpha beta, we can replace it with 3. So C on A is 1/3. Anytime you have a denominator in these types of questions, multiply everyone by the LCM. So the denominator, the LCM of 3 and 3 is 3. So we are going to visit everyone and multiply everyone by 3. Of course, this is equal to 0, but if you multiply anything by 0, you will get 0, because we have to multiply the other side by 0. So we will get 3x squared. The 3 and the 3 will cancel out to give you a positive 2x. 3 will cancel out with 3 to leave you with the 1. And this is the answer. This is the new quadratic with these two roots, with 1 on alpha plus 1 on beta. All right, let's try another example. All right, using these same values, we're using the same quadratic here, but instead of 1 on alpha plus 1 on beta, let us try, let me see. Let the two new roots be alpha squared and beta squared on alpha. So you have a new quadratic with two new roots. The roots are no longer alpha and beta. The new roots are alpha squared on beta, and the new beta is beta squared on alpha. So that means this is the new alpha. I'm going to call it alpha 1. And this here is the new beta, beta 1. And of course, this is the new quadratic we are trying to find. X squared plus b on ax plus c on a. Our job is to find b on a and c on a using these new roots. To find b on a, we are going to take the new alpha root, add it to the new beta root, and whatever we get, make it the opposite. So let's try this. Minus open brackets alpha 1 plus beta 1. And when we finish simplify this, we will get b on a. So alpha 1 is alpha squared on b plus the new beta is beta squared on alpha. And of course, we have to find the LCM here, beta alpha. This into this will leave us with alpha. Alpha by alpha squared is alpha cubed. Alpha into this is beta. Beta by beta squared is beta cubed. So all we need to do is work this out and apply a minus sign there. Run into a little problem here. Alpha cubed plus beta cubed. We need to get this special formula here. Alpha cubed plus beta cubed. So what we need to do is throw it into this formula here. We'll work the underneath is easy. Beta alpha is the same thing as alpha beta. And alpha beta we can replace it with minus 3. It's just the top guy we need to simplify a little bit. So it's alpha plus beta, and just writing back this formula here. Big square brackets, alpha plus beta squared minus 3 alpha beta. Right. So we're going to work out, this will help us work out the top, but at least we know the underneath is minus 3. So let's take a few seconds and work this out. To be honest, I didn't expect this question to turn out like this, but that's okay. Alpha plus beta is 2. Alpha plus beta is 2. We'll have to square it. And alpha beta is minus 3. Remember, two negatives make a positive. So 2 squared is 4. Minus 3 by minus 3 is positive 9. And when we get this, we have to multiply it by 2. So 4 plus 9 is 13. 13 by 2 is 26. So that means the whole top here works out to 26. So I'm going to have to erase this. I really need the space. So if you didn't take it down, pause the video and take down the working. Right, so 26. So the top works out to 26. The underneath is minus 3, and we have a minus sign waiting here. Two negatives make a positive. You're going to get 26 on 3. So we just figured out B on A. We get B on A when we work out this and apply the minus sign. And I did apply the minus sign to get a positive. Erase B on A, put positive 26 on 3. Let's work out C on A. How do we work out C on A? We have to take the new alpha and multiply it by the new beta. Let's work that out. So what we're already looking at is alpha 1 multiplied by beta 1. So we have alpha 1 multiplied by beta 1, which is, it's a different color here. Alpha 1 is this guy here. So it's alpha squared on beta multiplied by beta 1, which is this. This is actually going to turn out really, really simple. He's going to cancel out with him, and 1 beta will cancel out with one of the squares here. So the whole underneath just reduces to 1, and we just end up with alpha beta. Alpha multiplied by beta. Alpha beta is negative 3. So C on A is negative 3, and a positive and a negative will give you a negative. Now this is obviously negative 3 on 1. We have a decimal. I think we should visit everyone and multiply by the LCM, which is 3. So we're going to multiply by 3, by 3, by 3. Remember, the other side is equal to 0. Just don't have space. 3 into 3 is 1. 1 into 3 is 3. Can't really do anything here. The final answer is 3x squared plus 26x minus 9. And that's the quadratic with these two new roots. All right. So that's one of the harder questions you can get in the exam. Right? Sorry I didn't get a chance to use this formula here. I would have liked to have a question in this video with that particular formula, the alpha squared plus beta squared. But we did a much harder question today. So I'm hoping if I get a chance to do another video, I'm just going to pick a whole set of random questions from different past papers, or even from questions from students, and I could probably work them out from beginning to end. So after you do like about 6 or 7 examples more on this topic, and I think you're covered. You'll be okay for the exam. So anyway, take care and stay tuned for my next video. I'm not too sure which topic I'll be handling next, but I have a good, most likely I'm going to be handling either integration or logarithms. So until then, take care and have a good day.